All right, we're going to need to have sketching down the graphs down pretty well because, well, we've done it for the past 3 months, but besides that, this whole unit, which by the way is just one lesson, includes a lot of graphing from equations like this one. So we're just looking at linear graphs, just straight lines. And hopefully remember, if we're going to graph a line, a straight line, we should have it in slope intercept form. This one is not in slope intercept form. So that's the first thing we're going to do on this one. So we're going to take x plus 2y equals -4. And we've done this many times. But slope intercept form, y equals mx plus b, I need the x to be on the same side as the constant, so I need to subtract that x out, to zero it out. But if I do it to one side, principle of equality says I got to do it the other side as well. So x minus x, that's 0, so that zeroes out just like we want. We'll drop the 2y, which now equals, I put the x term in front, and then the constant behind it. So we can't combine those because they're not like terms either. So I got 2y equals -x minus 4, but I don't want 2 y's, I just want 1 y. So to make that 2 a phantom 1, I'll divide it by itself. But if I do that, I got to do it to all the terms. Okay? So I will show that phantom -1 with the x as well. So I got a phantom 1 y now, which equals, that'd be -1 over 2x, and then -4 divided by 2 is -2. So slope intercept form, of course, gives us a slope, which is represented by the letter m, which is -1 over 2. So the negative tells us that we would go down 1. And the 2 denominator tells us we would go to the right 2. Well, down 1 to the right 2 from where? That's where we need that y-intercept right here, the -2. So that's our b. B is the y-intercept at 0, -2 on this one. So I put that point on the graph, 0, -2, which is, since it's the y-intercept, it should be on the y-axis. And I go down 1 to the right 2 from there. So that's this next point, and I can continue this pattern to find these other points. In fact, since that takes me to the edge of the graph, as far as I can go the other direction as well. So that's left 2, up 1. Left 2, up 1 again, right? And then I get this, something like this line right here, okay? So I've been doing a ton of that, and now we're going to be doing even more of it in this Unit 5, Lesson 1. Solve systems of linear equations by graphing. So that brings us to the objective. I know a solution to a system of equations is the point of intersection between the two lines. Take 1 minute and copy this down, please. All right, now you'll hear this word a lot, and in fact, systems, of course that's what we're looking at in this unit. But in 9th grade, you're going to be looking at systems in at least 2 other ways. Maybe 3, but maybe that comes more in like 10th or 11th grade math. But a system just indicates that we're looking at 2 or more equations. For now, we're just going to look at 2 equations, okay? So the point of intersection between the 2 lines. So the 2 equations indicates that on a graph, we're going to be looking at 2 lines, okay? And specifically, we want the point of intersection. So yeah, this is our first method, and it's the only method we're going to be going over in 8th grade is solving these by graphing, which is why in the bell work we did a graph, because, well, we should have been doing that. We've been doing a lot of it. And in fact, the mastery quizzes from Unit 3, there's still several of you that need to pass those, so you'll need to do those as soon as possible. But yeah, if you can't graph lines in Unit 3, then in this unit, which is just one lesson, you may find this extraordinarily difficult. Remember, too, if you can't pass the mastery quiz, you can't pass this class. But if you can pass the mastery quizzes, then it's impossible to fail the class. So the solution is found at the point where the 2 lines intersect. Okay, so if we were to look at a graph like this one, and we had 2 lines on this graph, doesn't really matter what they look like. I don't know, something like this. I guess that's more what I wanted. So So you may graph a line like this one, and then it's possible you may have another line like, oh geez, I don't know, something like this, okay? Who knows what the lines will look like? Sometimes they'll just be straight and horizontal and vertical. Doesn't really matter, but the solution to a system like this, when we have two lines on a graph, is the point where the two lines come together. So I'm going to pretend like these two came together at that point. And it's just the ordered pair. This would be the solution to this system. So this ordered pair, I see the x is at -5 there. And then the y there is at 6. So this would be the solution, the actual solution to this system. Now, if we think about what a solution to a line means, or a point on a line, it would indicate that whatever this equation is for this red line, it would make it a true statement. And the purple line, whatever equation this came from, it would also make, this ordered pair would make it a true statement, okay? Now, in the first couple questions we're going to see, it is possible that you can have a point be true for just one of the equations, like let's say this point. So this ordered pair that I have in orange there, which is 7, -5, it would make the purple line true because it's actually on that purple line. But see how it's not on the red line right here, right? So that would make it, that would mean that it would make this equation from the red line false, okay? But only the green point would make it true for the purple and true for the red as well, okay? So it has to be true for both. Now, it is possible from time to time you may see a point that's just kind of out here, like this one. That is the ordered pair 10, 5. And we can see, since it's not on the purple line, it would make it false. And since it's not on the red line, it would also make the red equation false as well, okay? Because it's not on either lines. It needs to be on both lines in order for it to be true. And the only way that can happen, at least with straight lines, is if they come together at a point, okay? So just based on what we saw on the last slide with the objective, see if you can solve these two. You're just looking at 4,1 and -3,3 and seeing if it is a solution for the given set of system of equations right there. 1 minute, go. So these first couple questions are just asking us, really, is this the point of intersection for these two equations, or is this the point of intersection for these two? And the only way that can happen is if it makes both of the equations true, if I replace the two values that they give us from the ordered pair into both equations. Now, I'll remember, though, if I'm going to test both, but I'm going to start with the first equation. If I found that it was false, then it wouldn't be true for both, so I would know that it's not a solution to the system of equations, okay? So I'm going to start with x minus y equals 3. X minus y equals 3. And I have my ordered pair here. I'll put it in green. So I can see the x value is 4 and the y value is 1. So in my equation, x minus y equals 3, I replace the x with 4. And then I replace the y with 1. Because that's the x value is 4 in that ordered pair, and the y value is 1. And then I just see if it's true. So I'm going to put a question mark over the equal sign, because I'm not sure if it's true yet, although some of you do. And I say, well, 4 minus 1 is 3. And does 3 equals 3? Yes, that's true. So since this first one is true, of course, it means that 4, 1 is actually on the line. If you were to graph this equation, this ordered pair would be on that line. But is it going to make the second equation true? Let's find out. 2x minus 3y should equal 5, but let's replace the x and y values with the values they give us. So the x value from that ordered pair is 4, and the y value in that ordered pair is 1. Of course, you could just type this into the calculator with parentheses and all, and then it would actually simplify it for you, but I'm going to do it by hand. 2 times 4 is 8. 3 times 1 is 3, just order of operations stuff. And again, we're testing for truthfulness on this one. So does 8 minus 3 equals 5? Yes. So that is also true. So since it was true for both equations, 4,1 would be the solution to the system. So I'm going to say yes, it is the solution to the system. So that's number 1. 4,1 was that ordered pair. Now number 2, it gives us a different ordered pair. And I'll put this one in orange. Again, the x we can see is -3, and the y value is 3. So I need to test both equations, or at least one, to see if it's true or false. Again, I'm going to start with that first equation. It doesn't really matter which one you start with. But if I found that this equation was false, I wouldn't need to test the second one because it needs to be true for both in order for it to be a solution to the system. So I'm going to replace the x value with -3 there. And I'm going to replace the y value with 3 because that's the two values from the ordered pair, x and y. So 3 times -3 is -9 minus 3. And yeah, we are testing to see if this equals -12, so question mark over the equal sign. -9 minus 3 gives me -12, which does actually equal -12. So that's true right there. Since it's true, I do need to check the second equation and see if it's true. So that's x minus y equals 0. And I know the x value is -3 from the ordered pair. And the y value is +3 from the ordered pair. Now be careful on this one because if you do this in your head, a lot of students make the mistake and say -3 minus 3 is 0, but that's not true. We are testing for truthfulness, so we got the question mark over the equal sign. Just doing the calculator just to make sure. -3 minus 3 is actually -6. Well, -6 does not actually equal 0. That's false. Okay. Since it's false, then the original ordered pair there, -3, 3, is not a solution. So I'm going to say no, it is not a solution. But again, it's not a solution to the system, which means it needs to be true for both. Eventually, it's possible you could see up to like 3 or 4 equations. Most likely 3, though. All right, here's another system. This problem's different, of course. You're going to actually have to graph this one, both these equations, the system, and then see if you can find the solution to this system. 1 minute, go. All right, well, let's solve this system by graphing then. Now, neither of these two equations are in slope-intercept form. And in order to graph the line, we do need them in slope-intercept form. So let's go ahead and start that out. And I'll start with the x minus y equals 2. So to change this into slope-intercept form, I would have to subtract x. If I do it to one side, the principle of equality says I got to do the other side. Why subtract x? Because then it zeroes that x out. It makes it a phantom 0. So now I have -y equals -x and plus 2. Again, the 2 and -x, I can't combine those because they're not like terms. Well, the coefficient of y there, I'm going to show that phantom 1. And I need to get rid of it or make it a phantom positive 1. So I'm just going to divide it by itself. But if I do it there, I got to do it to all the terms by the principle of equality. So that makes that a phantom 1, phantom 1y. So now in the coefficient of x, that's -1 divided by -1, which is positive 1, x. And 2 divided by -1 is -2. Now the coefficient of x1, I'm gonna make it 1 over 1 so I can see the rise and run. So I can see my slope, 1 over 1. And that means, since it's the 1 in the numerator, since it's positive, that means I would go up 1. And then the 1 in the denominator is positive, so I would go to the right 1. Up 1, to the right 1. And then I need my y-intercept, which is just that -2 right there. But remember, it's an ordered pair, so make sure it's 0, -2. So I put this ordered pair first on the graph, and then I'll use the slope to find all the other points. All right, so 0, -2 would be right here. And from there, I'm just going to use now we're going to go up 1 to the right 1. That's better. So up 1 to the right 1. What's this next point? Up 1 to the right 1. Up 1 to the right 1. Just continue this pattern. as far as I can go on the graph. Up one to the right one, up one to the right one. And we get all these points. Okay. Now I can go the other direction on the graph also. I'll just go, instead of up one to the right one, I'll go left one and then down one. See how that makes that same stair-step pattern, which is what we want. Left one, down one, left one, down one, left one, down one, left one, down. So that was a lot of points to put on the graph, no problem. Now before I draw the line through these points, I'm actually going to make the other line first. Okay, so I will draw the line, I'm just going to wait. And the reason why I'm waiting is because in this unit, when we're graphing, we shouldn't see any fractional or decimal values in the ordered pair that is the solution to the system. So we shouldn't expect any funny business like that on these problems. Now, when you get into 9th grade and you're solving systems with other methods, yeah, you'll see fractions and decimals, that's okay. But while we're just graphing right now, we shouldn't see any. So I'm going to take this second equation, which I'm gonna do in purple, and I'm going to change it into slope intercept form first, right? So x plus 3y equals 6, and I need to get rid of that x, so minus x from both sides. I'll zero that out, drop the 3y, and we can see that we can always change an equation that's in this form in the slope intercept form in 2 steps. So the negative x and positive 6 I cannot combine because they're not like terms. Now divide all the terms by the coefficient of y, which is 3. To make it a phantom 1, 1y, now I'm going to show the phantom 1 for the x, negative 1. So that's a negative 1/3 x, and then 6 divided by 3 is positive 2. So just from that equation, I can see my slope, m, is negative 1 over 3, and the negative tells us we'll go down 1. And the 3 being positive tells us we'll go to the right 3, rise over run. So rise is up and down, run is left and right. And then we have the plus 2 right there, which is the y-intercept. Again, that's an ordered pair at 0, 2. So I'm going to start with the y-intercept on the graph at 0, 2, right here. And then I'm going to use the slope to find all the other points. So that would be down 1 to the right 3, which is this next point. Down 1 to the right 3. Down 1 to the right 3. And you can see we've already found the point of intersection, where it's purple and red. But I'm going to continue to graph this line because I think it's good practice. So I was going down 1 to the right 3, so now I'm going to go left 3, up 1 to continue the stair-step pattern. Left 3, up 1. Left 3, up 1. And so I have all these points. And yeah, we can see the point of intersection between the red and purple lines. Once I draw them, it'll be this point right here in green. And what is that ordered pair right there? It appears to be the ordered pair 3, 1. So that is the solution to the system. But before we finish, I'm going to draw the line through the points. So there's the red one. And then we got the purple one, something like this. Okay, so again, if you checked, if we went back to the 2 equations, and you check 3, 1, right? So you'd say in the first equation, x minus y equals 2. I'd replace the x with 3 and the y with 1. And I see 3 minus 1 equals 2, so that would be true. And then in this equation, if I replace the x with 3 and the y with 1, that would make 3 plus 3 times 1 is 3. So 3 plus 3 is 6. And it also makes that second equation true as well. Which it needs to do in order for it to be the solution to the system. It has to make both equations true, not just one. Definitely not neither of them, but should be both. The only thing that's really new that we've seen so far is just that now we're graphing 2 lines instead of 1. Hopefully that's not too bad because we've been doing this now for about 3 months. All right, here's our next problem, another system. See if you can graph these 2. We'll give you 1 minute to do it, and then we'll go over it, all right? 1 minute, go. All right, here's our next system. Y equals negative 3x and 6x plus 2y equals 4. And what do we notice about this first equation? I'll do it in red. I'll graph it in red. Y equals negative 3x. That's in slope intercept form already. You just don't see the phantom plus 0 right there. That's not a problem, hopefully, because we've seen that before. But right away, I can see that my slope from this is just negative 3. It's a coefficient of x. But again, I'm going to show it as negative 3 over 1. So that tells me, since the 3 is negative, that would be down 3. And the 1 denominator is positive, so it would go to the right 1. And hopefully remember, when graphing these, I've always made the denominator positive, so I've only gone to the right. But it is possible for it to be negative, which means you'd go to the left. So there is our slope. And we also have the y-intercept there at 0, in this case 0, 0. So that's the b, right? 0, 0 here, which is just right at the origin. So now that I put that point at the origin, I'm going to go down 3 to the right 1, which gives us the next ordered pair. Down 3 to the right 1. That's the next one. And then down 3 to the right 1. Now, it is possible, I know there's still several students that are struggling with just counting these. They know it's down 3 to the right 1, but if you're going to count lines, like some of you have chosen to do, like if you start here and then go down 3, you would start here at 0. That's 0, 1, 2, and then 3. Okay? Now, some of you, and this has been good as well, some of you have been choosing to count blocks, which is good. So then you can see you count those 3 blocks. And then that would be down 3 and then to the right 1. There's the 1 block. Okay? Now, that's as far as I can go down 3 to the right 1, but I can copy these stair steps going to the left. So that would be left 1 up 3, left 1 up 3, left 1 up 3. And that's as many ordered pairs as I can fit on this graph. Now I'll draw the line just so you can see that you can if you choose to. Doesn't matter if you do it after like I did before or before like I'm doing right now. But that is the graph for the equation y equals negative 3x or y equals negative 3x plus 0. Let's do the next equation again. I'll do it in purple. 6x plus 2y equals 4. I need to change this in a slope intercept form. So 6x plus 2y equals 4. Again, we can do this in 2 steps by zeroing out the x's. So that's minus 6x on this one. To zero that out, drop your 2y equals, again, these two terms are not like terms to combine, the negative 6x and positive 4. And then divide all the terms by the coefficient of y, in this case 2. So that's a phantom one now. Y equals negative 6 divided by 2 is negative 3. So negative 3x, and 4 divided by 2 is positive 2. So I can see then that my slope, the coefficient of x, is negative 3. I'll make that negative 3 over 1. Which also tells us the rise and run. Since it's negative 3, that's down 3. And positive 1 is to the right 1. Down 3 to the right 1 from where? That's where we need the y-intercept, b, which is at 0, 2 in this case. Okay, that's that plus 2 right there. So I'm going to put 0, 2 first on the graph. There in purple. And then I'm going to put all the other ordered pairs on the graph using the slope. So I'm going to go down 3 to the right 1. It's this next ordered pair. Down 3 to the right 1. Here. Down 3 to the right 1. And I can fit one more right there. But I can go the other direction. So that'd be left 1 up 3. Left 1 up 3. That's as many points as I can fit. So let's go ahead and put this graph, this line on the graph. That looks pretty good. Now, just from the 2 lines we've graphed, we can see that there's no intersection between these 2 lines. In fact, we'll never see one. If we remember, slope indicates the steepness of the line, And for the red equation, we had a slope of negative 3 over 1. The purple equation, we had a slope, the same slope, negative 3 over 1. So the steepness is the same. And in addition to that, they're going through the y-axis at different points. 0, 0, and then 0, 2. Which means these two lines are actually parallel. And when you get two parallel lines, remember, just from the objective, that the solution to a system of equations is where the two lines will intersect. Well, when will parallel lines intersect? They never will. So this one just has no solutions. There is no solution to this system because the two lines are parallel. So when you see the slope is the same between two lines and the y-intercepts are different, those two lines are going to be parallel. Now, is it possible to have two lines that are the same line? Yeah, we'll see that example coming up. All right, here's our next problem. Just take 1 minute, see if you can graph this system and find the solution to this system of equations. Take 1 minute, go. All right, here's two equations, and yeah, this one is nice because both equations are already in slope-intercept form. Very generous. So, I'm going to start with this one. Again, I'm going to use the same colors to graph these. The first one will be in red here. And from that equation, I see the coefficient of x there is negative 2, so I know my slope is negative 2. But I'm going to show it as a fraction so I can see the rise and run. Since it's negative 2 over 1, the negative rise means it would be down 2. And the positive run means it would be to the right 1. So that's our slope there. And the negative 1 there is going to be part of our y-intercept. The ordered pair is 0, negative 1. So I have all the information I need to start with to graph the line. Starting with the ordered pair 0, negative 1. And then from this ordered pair, I use the slope to find all the other points. So that's down 2 to the right 1 from this point. Down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. So these are all the points I got, but I can go the other direction. Left 1 up 2, left 1 up 2, left 1 up 2, left 1 up 2, left 1 up 2. Okay? Now again, whether you graph the line right now or later doesn't really matter. I'll graph it later on this one. Just kind of alternate between the two. Let's go ahead and graph the purple equation. So this purple equation, the two things we need to make a graph are the slope and y-intercept. And yep, we got the slope, that's the coefficient of x. And I'm going to show it as negative 1 over 2. Again, rise over run. The rise is negative, which means it would go down 1. And the run is positive, so it's going to go to the right 2. So there's rise over run. That's our slope. And we also have the y-intercept there, the 2 there, which makes it the ordered pair 0, 2. And with the slope and y-intercept, I'm ready to graph this. So I put the ordered pair 0, 2 right there. And then I use the slope to find all the other ordered pairs. So I got negative 1 over 2, so that's down 1 to the right 2. It's this next ordered pair, down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. Now from going to the right here, down 1 to the right, I can see that the two lines are getting farther and farther away from each other, which means if I go the other direction, they should get closer. So that would be left 2, up 1, and yep, we see that point of intersection. Left 2, up 1, left 2, up 1. And now, since they intersected, as I continue, they'll get farther away again. Okay? So let's go ahead and put these 2 points on the graph here. 2 lines on the graph, rather. So there's the purple one. And now the red one. There we go. But again, the solution to the system is where the 2 lines intersect. That's this point right here. That ordered pair looks like the x value is negative 2. and the y value is 3. So negative 2, 3 would be the ordered pair that would make both of these equations true. And you can check again. That'd be negative 2 times negative 2. That's 4 minus 1 is 3. So that makes this true. Negative 1/2 times negative 2, that's 1, plus 2 is 3. So it makes both equations true, which it should do. All right, and take 1 minute and try this one out. See if you can solve this systems of equations by graphing, all right? 1 minute, go. All right, let's graph these two. Y equals negative 5. Yeah, we got, this is actually in slope intercept form, though it may not look like it. And yeah, we've gone over this several times, so we should know what this graph looks like. But just in case we've forgotten, we could write this in slope intercept form as y equals 0x minus 5. It becomes a phantom 0, which tells us the slope is 0. I'm just going to make it 0 over, I'll make it, well, 1. Which means that the slope would be up 0 to the right 1. There's our slope. Well, up 0 to the right 1 from where? That's our y-intercept. We need that y-intercept, which is at 0, negative 5. So 0, negative 5 right here. And then I use the slope to find all the other points on the line. Up 0 to the right 1 would be this next point. Up 0 to the right 1. Up 0 to the right 1. Up 0 to the right 1. And then we can hopefully remember that this is a horizontal line. But I still got to graph this other equation. So that shows us a slope of negative 2. You know, since we want rise over run, I'll show it as a fraction. And since it is negative 2 over 1, that would be down 2. And then to the right 1. Well, down 2 to the right 1 from where? That's the y-intercept again we need, which is that negative 9 right there. But again, it's an ordered pair at 0, negative 9. So 0, negative 9, boom, right there. Now the problem with this graph at this point is if I go down 2 to the right 1 from that purple point, I end up off the graph. So I've got to go in the other direction instead, which now instead of down 2 to the right 1, it'd be left 1, up 2. And again, that creates the same stair steps. So we get this kind of graph. Left 1, up 2, left 1, up 2. I'm just making the same stair steps going backwards. So I end up with all these points. Yeah, we can draw the line that goes through them. Not that you have to yet, but you should eventually. And yeah, we can see this ordered pair where the purple line intersects or goes through that red line. So the y value, the x value rather, looks like it's at negative 2 with the y value at negative 5. So negative 2, negative 5 is the solution to this system. Now something else I want to point out is that up here it said y is negative 5. If it tells you what y is in the system, then that's what it should be in the solution. Y equals negative 5, so negative 5 as y was one of the values there. Now keep this in mind as well. If you see x equals a number, like we've seen before, those are just straight vertical lines, straight up and down. I don't think we're going to see any of those in the examples, but you may see some of those on the assignment. All right, and this is our last example, so take 1 minute, see if you can solve this system of equations by graphing, and we'll go over it in 1 minute. 1 minute, go. All right, solve this system by graphing. No problem, let's do it. But before we graph this, and yeah, I'll be doing this one in red, let's change these into slope intercept form, okay? So that's a negative 2x plus y equals 1. So I'll zero out the negative 2x's by adding 2x to both sides, which will zero that out. And now I'm left with y. I'll drop the y equals 2x and positive 1. Now the coefficient of y is already a phantom 1, so I don't need to perform that second step. I can see right here that my slope is 2, or 2 over 1. And since the 2 is positive, that would be up 2. And then to the right, 1. Up 2 to the right 1. Well, up 2 to the right 1 from where? That's our y-intercept, which is that plus 1 right there. But again, it's an ordered pair, 0, 1. And then we'll do the second equation in purple. 4x minus 2y equals negative 2. So I'm going to subtract 4x from both sides. To zero out my x's, drop my negative 2y. Remember, it keeps that operation to its left as its sign. So that's a negative 4x and negative 2. Again, we cannot combine those because they're not like terms. Now divide all the terms by the coefficient of y, which is negative 2, to make it a phantom 1. So now y equals negative 4 divided by negative 2 is 2x, and negative 2 divided by negative 2 is positive 1. So that tells us the slope there is 2, but again, I'm going to show it as a fraction, 2 over 1. And since the 2 is positive, that would be up 2. And the 1 in the denominator is the run, which is to the right 1. Up 2 to the right 1 from where? Well, that's our y-intercept that we need. On this one, that's a plus 1 right there at 0, 1. So let's go back to the graph then. Yeah, we have all the information we need. I'll start with the red equation, starting with the ordered pair 0, 1 right here. And then my slope being 2 over 1 means I would go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. All right, and I'm going to continue this backwards, so left 1 down 2, left 1 down 2, left 1 down 2, left 1 down 2, left 1 down 2. And I'll go ahead and make this graph. Graph the line there. Something like that. And then let's do the purple line as well. So 0, 1, that would be the purple ordered pair right there. And then the slope, up 2 to the right 1, gives us this point, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And we can see that all these ordered pairs are falling on the same line. So even when I graph the purple line, let's see if I can do that a little better. Something like this. What we find is that these two lines, and again, the objective is the solution to a system is the point of intersection between the two lines. But this one, it doesn't just have one intersection. We've seen an example with no intersections. This one it's intersecting everywhere. So in actuality, this one we would say just has infinite solutions. Because it's going to intersect here and there 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 and everywhere, even places off the graph out here and to the side. Okay? So this one, we won't declare any one specific solution. This one just has infinite solutions. So that brings us to the story of lines. And this is nice because lines, they'll either intersect everywhere, like we see here, at least straight lines will, which is great because they have a lot in common, right? If we remember this example, they have a lot in common, right, with the slopes. But it's unfortunate because these two lines will never meet. So they have a lot in common, but they'll never meet. Any other lines like these two, unfortunately, they will meet once, but then they'll drift apart forever and ever and ever. Which, as a math story, is kind of sad. That's our objective. I know a solution to a system of equations is the point of intersection between the two lines. Of course, we saw an example that had no intersection, so the two lines were parallel, in which case there was no solution. Or we saw in that last example where the two lines were the same line, which means they have infinite solutions.